we would like to talk about functions as the graphs. The graph of an equation or function is the picture that represents all solutions or order pairs for that equation or that function. Remember, if every value in the domain, which we often use x for the domain, correspond to only one value in the range. Again, we often use that y, then the graph is a function. If any value in the domain corresponds to more than one value in the range, then the graph is not a function. So to determine if a graph is a function, we will use the vertical line test, which states that if a vertical line intersects the graph at more than one point, then the graph is not a function. If you pass a vertical line through and doesn't intersect out more than one, that is a function. Are this relation also function? I'm going to be using vertical test because these are graph and pass a vertical line from left to right through my function. At any one point, my vertical line is only every touching the blue function at one place. So for every x value, there is only one value for every x value. On this red line, there is only value for every x. There only as part that line from left to right, I realize that there are places where we can x value trying to be mapped to different y values. So this first relation is also function. Let us look at our second graph. When I take my vertical line, and you may want to just use your pencil and drag your pencil from left to right across your graph, immediately see a problem that intersect my blue relation at two different places in this relation or this graph also function, and the answer is not, it is not a function. It does not pass through the vertical line test. In our third example, when I pass a vertical line from left to right, you may use your pencil. Every red line that I draw only across at most only place. In this case, my graph is the function. Continuing with the function as the graph, we can also find values of a function by looking at the graph. To find a function's value, go to the x coordinate that's given our input and are going to look at that on the x-axis. Your answer is on the y coordinates. At that point, let us look at the first graph and assume that this function is named is f. I would like to find f of -2, so I'm going to -2 on my x-axis because -2 is my input or my x value. So -2 on my x-axis, I would like to what is the corresponding y value at the point on the graph. Well, you can see the point of the graph is -2, -1. So therefore, f of -2 is equal to -1. The corresponding point is -2, -1. Next, I am going from looking for f for -1, x -1, and I look the graph corresponding y value. The corresponding y value there is 0. The corresponding y there is -10. Next, if I am trying to find f of 1, go to 0 corresponding on the x-axis. I down find the coordinate y when x is equal to 0 and the value is 1. The order pair associated is 0, 1. To find f of 1, I go to the x-axis at 1 and I look either up or down, find corresponding y value. The corresponding y value here is to the associated order pair is 1, 1. And lastly, f of 2, I am looking for 2 at the x-axis. I am looking for down to find the corresponding y value. In this case, the corresponding y value is f3. The associated order pair would be 2, 3 on the next graph. I am trying to find f of negative 3, so I am going to go to negative 3 on the x-axis and find the graph corresponding a y-coordinate which happens to be 0. f of negative 2, I am going on the x-axis to negative 2 and look or down in order to find the graph corresponding value at x equal to, and the y-coordinate here is 1 at f of 0 when go to 0 on the x-axis, and when look up or down in order to find the corresponding y value at the function. In this case, the corresponding y value when x is 0, y is 3, and the order pair there would be 0, 3. If to 1, I'm going to of the x-axis and looking for down in order to find the corresponding y value on that graph, which is again at 3. And lastly, f of positive 3, look at 3 on the x-axis, which happens to give me y